Welcome to the exercise. This is the video of the answer of the exercise. We will start with the exercise of the 19th of October, 19th of October 2022. Basically, we will start with exercise number 1. Please say that we have this compound. Okay. And the first thing is to name the following compound. Okay, in order to name the following compound, the first thing that we need to do is basically check the longer chain. In this case, it's a cyclic compound. That means that the longer chain will be the cyclic compound is a 5-member ring will be a cyclopentane. Okay? Then we will check the priorities. We have 2 halogens. This is the halogen with higher priority because it's the one that is a higher mass, higher atomic number, bromine. We will put 1 bromine, and then we will try to do that the fluorine will have the lower number possible. We start 1, 2, 3. This is number 3. 1, 2, 3, 4. This will be number 4. I mean that the numeration will be 1, 2, 3. That means that will be 1 bromine, 3 fluoro, cyclopentane. Then they say that we say the stereochemical descriptors. Fluorine is coming to us, while the bromine is inside the whiteboard. That means that will be a GANT. And the next thing is to check the stereoselectivity. Will be R, will be S. In order to do this, what we need to do is to check each chiral center. Basically, we have 2 chiral centers, the bromine and the fluorine, and we can put our I here. If we put our I here, we have bromine in our left, hydrogen in our right, C2 up, and C5 down. Okay? We give the priorities. Bromine is priority number 1, it's a heavier atom. Then C2 will be priority number 2. Why? Because we have the fluorine closer. C5 will be number 3, and finally hydrogen will be number 4. We change, put the 4 down. Remember that we have to switch 2 at the same time. That means that we will have 4, 3, 1, 2. Anticlockwise will be S. Okay, if we do exactly the same in the other atom, I watch it from here. Remember that when we are doing the cross system, what we need is that the 2 substituents that are in the horizontal has to come in the direction where we are. That means fluorine will be in my left, hydrogen in my right, and then C2 up, C4 down. And again, I will give the priorities. Highest priority, the fluorine. Okay. Then the second priority will be the C2, because the bromine is closer to C2. 3, and the hydrogen 4. That means we change the numbers in order to put the 4 down, and we have 4, 3, 1, 2, again anti-clockwise S. That means that this compound will be 1s, 3s, 1 bromo, 3 fluorocyclopentane. Okay? Good. Go for question number 2. Okay? We have this compound with the cycloxane, okay, with this constituent, yellow, bromo, and fluoro, all are in our direction. Okay, and they ask, draw the two different chest conformations and tell us which is the more stable. Well, we can draw the two chest conformations. Okay, and I enumerate 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1 iron up, 2 bromine up. I draw the hydrogens in order to see that the bromine is the one that is in the higher position. And number 3, fluorine up. Then we draw the other chain. Okay? And I do the same. I enumerate 1, 2, 4, 5, 6. Here up. I put the hydrogen in order to see the diagram is the subsequent that is in the upper position. Number 2, bromine up. And number 3, fluorine up. Okay? These are the two conformants, the two chair conformants. Which will be more stable? Basically, the more stable will be this. Why? Because here you can see that the two biggest constituents, iron and the fluorine, are in equatorial, while only a bigger constituent like bromine is in axial. 2 equatorial, 1 axial, and the bigger one, that is the iron, is in equatorial. That means this makes this more stable. Then the other question is, if this compound, the compound that we draw, has a specific rotation of -45, which will be the specific rotation of its enantiomer? Remember that enantiomers have the same qualities. Okay, they have exactly the same boiling point, melting point, etc. But the specific rotation is with the opposite side. That means that if this is -45, the enantiomer will be +45. Okay? Good. And we can erase this and we can start the number 3. Number 3 is draw the 2s, 3r, 2-fluoro-3-methylpentane. If it's a pentane, I draw the main chain 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And they say that in position 2 we have a fluoro, and in position 3 we have methyl. Okay? Now we have to define which dialect is here. In order to do it, what I will do is I put this coming cost, and I will check which is the, if it's S or R, and then if it's the same, I will keep it. If it's the opposite, I will change the order. I will throw from here, for example. Okay, I throw fluorine, hydrogen down, C1 and C3. If I use the priorities, it's 1, the fluorine, 4, the hydrogen, C1 will be 3, and C3 will be 2 because it has higher priority. The 4 is upside down, that means I make this clockwise, this will be R. But in our case, they say that we need to have the X. That means that instead to put the fluorine in front of us, I will put the fluorine behind us and will be the right answer. I do the same for the metal. I go in front of us and I saw it from here. If I saw from here, I have metal up, hydrogen down, C4 on my left and C2 on my right. If we check the priorities, the C2 will be number 1, number 4, C2 will be C4 will be number 3, number 2, sorry, because it's a metal, and the metal will be number 3. I do it again, this is clockwise, it's against R, and this time is what we want, isn't it? Yes. Free R, fluoride. That means that if we draw it like this, this is the right configuration. This down, this up. Okay? Right? Good. Okay. Then we go for the next one. That is telling us that we put some examples of different type of compounds. The first example is conformants. What is conformant? Conformants are two compounds that the only difference is a rotation, of a carbon-carbon rotation. That means, for example, we can draw a Newton projection, okay, of the same molecule. Okay, this, and then I rotate one of the carbons. I rotate the carbon that is behind. For example, I put the CH3 staggered, but now in this position. And these two are conformants of the same molecule, but with different rotations. Isotopes. Isotopes, remember that is one atom is isotope of another when the only difference is the number of neutrons. Typical example, hydrogen 1 and hydrogen 2, that also is called deuterium. Okay? Constitutional isomers. Constitutional isomers are two compounds that have the same formula, the same molecular formula, but differs in the connectivity. Typical example,